Hello, today we're going to talk more about exponents, but this time we're going to add on the power of a power rule. So power rule, there's kind of two ways to think about it. I have these written in green here. Basically what's going on with our power of a power rule is we're dealing with when we have exponents on the inside and outside of parentheses. This is almost like the distributive property for exponents. If I have an exponent on the inside and an exponent on the outside, I distribute or multiply those exponents together. Likewise, for the kind of part 2 of this rule, if I have an expression inside parentheses and an exponent on the outside, everything on the inside gets that exponent. So x would turn into x to the b power, y would turn into the a times b power. That's what we're going to focus on for today. When I talk about everything on the inside of parentheses getting the exponent, that includes the coefficient. So any powers you see also get taken to the coefficient. So let's dive right into one. Everybody on the inside needs to get this 4th power. So as an in-between step, this is not my final answer. I'm thinking 2 to the 4th, and then I'm just multiplying any existing exponents by 4. For p, 2 times 4 is 8. For q, 3 times 4 is 12. And for r, 4 times 4 is 16. This is almost what I want my final answer to look like. The only thing I don't like about that for final answer is I don't want to see 2 to the 4th. I want to see what number 2 to the 4th actually is. 2 to the 4th means 2 times 2 times 2 times 2, which you can do in your head or you can do in your calculator. No matter how you do it, you should get 16. So my final answer, I don't want 2 to the 4th, I want 16, and then all of my exponent stuff for my variables, that's not what I wanted to write. Everything else I want to stay the same. So this right here in pink is your final answer, not the blue. The only part about the blue I didn't like was that 2 to the 4th. If you're really good at dealing with powers, you can skip right from here to here and not show the blue step. Let's try another one. So we're thinking 4 to the 2 or 4 squared, m to the 2. If it helps, you can think of the 1 power there. 1 times 2 is 2. N to the 2 times 2, which is 4. P to the 4 times 2, which is 8. Again, the only thing I don't like about that final answer-wise is this right here. What number is 4 squared? 4 squared means 4 times 4, which is 16. Everything else was fine. So here's my final answer. 16 is my coefficient. Let's try a couple more, and then we're going to, with the rest of these we're going to do today, we're going to do a total of 8 problems today. With the rest of these, I want to go back and combine power rule with the other rules we've learned so far. Sort of like other times in math, if you see parentheses, that's usually where you start. That's exactly what we're going to do here. We have some product rule stuff happening here because of multiplication. However, it's going to be much easier to simplify this whole expression if we take care of product rule stuff first. So that's where we're going to start, is with this part right here. That marker is not very happy, so we're going to put it away. So I'm going to do 2 to the 4th, which is 16. This becomes x to the 4th. Y to the 4 times 4 gives me y to the 16. This part hasn't changed, so I'm going to leave it exactly the way it is. Now, I know this is not a final answer because I see x in multiple places, I see a y in multiple places. We do not want that. So to finish this off, I need to think about what rule do I need to use next. I see multiplication. Multiplication means I'm using product rule. I'm going to add my exponents. 16 is the only coefficient in the whole thing, so 16 will stay our final answer coefficient. You could also think 16 times 1 is 16. And now from here I'm using my product rule. For my x's, x to the 4 times x to the 3, I add 4 plus 3, I get x to the 7. For the y, same drill. 16 plus 4 gives me y to the 20. Now I can consider this my final answer because I have a coefficient, a x exponent, and a y exponent. Note, you may have noticed that our exponent answers are kind of bigger. That just happens when you start taking powers, you're going to run into bigger exponents and usually bigger coefficients than what we've seen so far. Not a big deal, just bigger numbers. Same idea with the next one. we are going to start with the power of a power stuff. So this expression right here, I'm going to leave the same. I'm going to leave the times dot there so I don't forget about it. I'm going to do this power to a power part. Once again, I have 2 to the 4th, which is 16. I have x to the 4th, and this is very similar to the last problem. Y to the 4 times 4 gives me y to the 16. I'm not done yet though. I want to see one coefficient, one x power, one y power. Coefficient wise, 2 times 16 is 32. X's, x to the 4, x to the 4. When I add 4 plus 4, I get x to the 8. And y's, it's like a hidden 1 here. 1 plus 16 gives me y to the 17. We're going to do a few more. We're going to continue building on with our other rules. Just give me a moment to get things reset for us. Okay, here we go. So again, we are going to continue just kind of mix all the rules we've learned together. Just like we talked about in the last few problems, whenever you see parentheses, aka power, that's where you're going to start. So I'm going to start in the numerator here by doing my power of a power stuff. First thing is 2 squared, which is 4. I get q squared. For p, 2 times 2 gives me p to the 4th. For r, 3 times 2 gives me r to the 6th. Down in the denominator, everything there stays the same because I haven't touched it yet at all. Does that look like a final answer? It does not. Remember, final answers, we only want one coefficient and one of each of our variables. So, final answer coefficient, I have just 4. So I'm going to have just 4 in my final answer. For q's, q to the 2, q to the 1, remember that when we are dividing we subtract. 2 minus 1 gives me q to the 1. Remember that q to the 1 is the same as just q. I'm going to choose to write as q. If you want to write q to the 1, go for it. For p's, 4 minus 2 gives me p squared. For r's, 6 minus 1 gives me r to the 5th. If you have your, I know usually I go alphabetical order, I didn't this time for some reason. If your variables are written in a different order, not a big deal, as long as you have coefficient 4 in front and the right power on each variable. We are now done. Let's try another similar one. We are going to start right here with our power of power stuff. I get j to the 3rd. For h, 4 times 3 is h to the 12th. For k, 3 times 3 is 9. All over 2hj squared. So that part hasn't changed yet. Now, coefficient-wise, what we have written now, stuff over 2, is like having a coefficient of 1/2. If it helps, you can write that 1 in there. 1 over 2 doesn't reduce. A lot of times people want to put that 2 up top, but 1 over 2 is not the same as 2. We need to keep that 2 in the denominator. If you'd like to write the 1 in there, you can, but you don't have to. Totally up to you. So my final answer will have a 1 coefficient up top, 2 coefficient in the denominator. I can't really do anything with my coefficients. For my variables, I have h to the 12, h to the 1. When I subtract those, I get 12 minus 1, which is 11, so I'm going to have h to the 11. J's, 3 minus 2 gives me j to the 1, or just j, however you want to write it. And then k, nothing is going to change about that because that's the only k I have in here. So I'm going to just have k to the 9th. final answer can look like this, or you can skip writing your 1, and your final answer will look like this. If you were doing something multiple choice, they probably wouldn't write the 1, just a heads up. All right, the last 2 are as crazy as it's going to get for now. We are going to be combining all 3 of our rules together. We will see some power of power stuff, we'll see some product rule stuff, we'll see some quotient rule stuff, all happening in the same problem. Looks really scary, but just take it one step at a time. So I'm going to start right here with my power of power. I get p to the 4th. For q, 3 times 4 is 12. Everything else about that problem is going to stay the same for now. So I like to rewrite it just so I know it's not going anywhere. You can do things however makes sense for your brain. Now, let's look at numerator, let's look at denominator. Which part has something that can still be simplified? The part that can still be simplified is the numerator. So we're going to use our product rule first. So in the top of that fraction, we're going to be adding exponents together for like exponents. So I have p's, 4 plus 4 gives me p to the 8. I only have one item with a q in it, so that stays the same. I have only one item with an r in it, so that stays the same. And then I did not mean to write this r down here. I got carried away. Sorry about that. So we shouldn't have any r's in denominator for those. I just made a mistake when I was writing this out. And our denominator has not changed. Am I completely done yet? Not quite, but I'm almost there. This is not a final answer because I only want to see one of each variable. Since it looks like division, I need to use my quotient rule, meaning I need to subtract my exponents. So I'm going to go with p's. P to the 8 minus 3 makes p to the 5 for our final answer. For q's, 12 minus 3 gives me q to the 9. And then r's, I only have one lonely r in that whole problem. It's going to stay what it is. So this right here is how this completely simplifies down. Notice that I only have one of each variable in my final answer, which is what we are after. Last one, very similar, but it had kind of a lot of steps, so let's just try one more like that. We need to start right here with our power of a power. Everything else is going to stay the same. Let's do the power of power part. 2 to the 4th is 16, so I'm going to get times 16, n to the 4, p to the 4. Now looking at our fraction, what can we simplify? Do we have things to simplify in the numerator or in the denominator? We have things to simplify in the numerator, so that's what we're going to do next. 1 times 16 is 16, using our product rule. We only have one m item in the whole numerator, so that's going to stay m squared. For n's, I have n to the 1, n to the 4, 1 plus 4 is 5, p's 2 plus 4 gives me p to the 6. Denominator still hasn't changed, so I'm just going to kind of keep writing that down. And now let's deal with our final answer. It's all division, so remember for division we're dividing our coefficients, subtracting our exponents. 16 divided by 2 is 8. M to the 2 minus 1 is going to be just m to the 1 or m. N's, n to the 5 minus 1, oops, 5 minus 1 gives me n to the 4th. And then for p's, p to the 6 minus 2 also gives me, oh, that should be a p. P to the 6 minus 2 gives me p to the 4. I am now finished because I have a coefficient and a power of each of my variables, so I am done. That is it for exponents for today. Have a great day.